Assalamu Alaikum, my name is Shumas. You are watching my YouTube channel. In this video, we will solve a problem of mass balance without chemical reaction. So for solving the problem, first step is to make your problem right in this form. So it will be easy you to solve. So the first step I have done that. I have written this problem in this form. After this, the second step is to find the degree of freedom. So degree of freedom, I have already told you I have already explained in my first video that it is number of unknowns minus number of independent equations. So what is the number of unknowns for this problem? So you see that this 80 is not present. So it is unknown to us. So now the number of unknowns minus number of independent equations. So here you can see that we don't know is the flow rate of A. After this, all the things have been specified for our B inlet. So this is P and its flow rate has been given to us. So the thing that is unknown is acetic acid and water. So now as we know that the combination of these two fractions will be 1. So now if we know only water or acetic acid, the other thing will be known by minusing it from 1. So now here will be the number of unknown also will be 1. So the overall number of unknowns to us is 2. And how many independent equations are present? The number of independent equations refers to the fractions, or you can say the entities or species that are present in your flow rates. So we are having only 2, acetic acid and water, acetic acid and water, acetic acid and water. So the number of independent equations is 2. So degree of freedom is equal to 0. So now we can say that we can solve this problem and we will have a unique solution to this problem. So let's start. In this problem we have to apply two balances. First of all will be overall mass balance. Overall mass balance, we will find what is A. From overall mass balance we can find what is A. And from component mass balance we will find the amount of acetic acid and water in your product. For solving this problem we will go to the general mass balance equation. So general mass balance equation is accumulation input minus output plus generation minus consumption. So now as this is a steady state process, so you can say that there is no generation is equal to 0 and consumption is also equal to 0. The thing that is entering is leaving. So no generation, no consumption. And for a steady state process, this accumulation is also equal to 0. For if you are having a batch process, then you will be having a accumulation, or you can have you will be having some amount of generation and consumption. Amount of term will not be equal to 0. For a steady state process, your accumulation, generation and consumptions are generally equal to 0, or you can say they are equal to 0. So what will be our equation that is left behind is input minus output equal to 0. So what are the inputs? The input is A plus 20. We are applying overall mass balance. Overall mass balance by using general mass balance equation is equal to output. What was the output? 100. So now I had forgot one thing. So now you can see that here is 20 kg per minute, here is 100 kgs per minute. So you can easily take basis of 1 minute. If you take the basis of 1 minute, so now you have you don't have to write 1 minute in every place. You can easily, after you solve the problem, you can easily say that our all flow rates are in per minute, but these bases must be same here. You cannot do this if your flow rate here is given as 20 kg per minute and here it is given as 20 kg 100 kgs per hour. So now in this case you will not be able to take basis as 1 minute. You will have to convert these minutes into hours or these hours into minutes. So when they will be same, here hours, you can take basis as 1 hour. Here I had already was having same minute, so that if these two are same, then I can take basis as 1 minute. So now as here already written, input minus output is equal to 100, so it is minus 100 is equal to 0. So now if we solve it, so what will be the answer? Answer will be 80 kg. So now here what will be A will be 80 kgs, or if in the form of basis it will be 80 kgs per minute. So now from the overall mass balance we have found our one unknown, that was A. After that now we have to find these two component fractions by component mass balance. So let's see how we can do this. So I will raise it. For finding these components, we will have to apply the component mass balance. The component mass balance again will be applied on the same mass balance equation, that was input minus output is equal to 0. So now for component mass balance, we will have to take individual components for applying their mass balance. So acetic acid, so I am applying the component mass balance for acetic acid. So weight of acetic acid multiply A will be the amount of mass of A in this flow stream, plus fraction of again acetic acid in B. The thing that we have to find is the weight of acetic acid multiply by the flow rate, that is P. So this is our component mole balance equation. So now what is the weight fraction of acetic acid? That is 0.10 multiply by A, that is 80. Weight fraction of acetic acid here is 0.3 multiply by 20. So it goes over here, and here acetic acid and this we want to find, multiply by 100. So now you have defined a equation. What will be? It will be 8, it will be 0.6, and it will be WA, and you can divide it by 100. If you will divide it by 100, so what will be 8.6 divided by 100? So after solving it, sorry, I had done a wrong thing. It is 6. So here it will be 14. So if you solve it, so WA will become 0.14. So here you can write the weight component or weight fraction as 0.14. So now we know that their sum will be equal to 1. So 1 minus 0.14 is equal to 0.86. So the amount of the weight fraction of water here will be 0.86. So in this way we have solved our first problem, that was mass balance without a chemical reaction. So now this is another problem, but its difficulty level is a little bit higher. So let's start solving this problem. Before solving any problem, that if it is given in descriptive form, you have to write in this form so that you can solve it easily. So first step is to find the degree of freedom before solving every problem. So degree of freedom is what? Number of unknowns minus number of independent equations. So what is the number of unknowns minus number of independent equations. So we will first of all we will find the number of unknowns. Here we don't have f, we also don't have d, we also don't have p. So the number of unknowns will be 3 minus number of independent equations. So this is E, H represents the ethanol and H2O is water. So the weight fraction of ethanol, so we are having two components, ethanol and water. So the number of independent equations, here you can see ethanol and water, ethanol and water, ethanol and water, ethanol and water. So the number of independent equations is 2. So now what is the degree of freedom is 1. So now if the degree of freedom is not 0, you cannot solve the problem. If it is positive, you will not solve the problem. So now for solving this problem or making the degree of freedom is equal to 0, you have to take basis. So you can take the basis of each any flow rate. So here if I take the basis as my feed is 100 kgs per hour, as I take my basis as 100 kg per hour as my feed. So now you can see that the unknowns have been reduced to 1 and 2. The number of unknowns have been reduced to 2. So now the degree of freedom has been changed to 0. So now you can solve this problem after the degree of freedom has been changed to 0. So now we will see that again there are two balances that we use. One will be overall mass balance and component mass balance. This problem we cannot use overall mass balance till this equation because we don't have D or P. If we were having D or P, then we will be having only one unknown, so we can apply easily the overall mass balance. We will apply component mass balance to find all the number of unknowns that are present. So now before starting, we will start with general mass balance equation, that is input minus output plus generation minus consumption. So now as again it is a steady state process, so accumulation will be equal to 0. There will be no generation and no consumption. Input will be equal to output. So you can write input is equal to output. So input is equal to output. So now we will apply our component mole balance. So first of all we will apply the ethanol balance, ethanol component mole balance. So what will be? It is the weight of ethanol in feed plus plus again this is our input. So weight fraction of ethanol multiplied by D is equal to, here you can say weight fraction of ethanol multiply P. Now we will input all the values that are known to us. So what will be 0.35 multiply 100 plus 0.85 multiplied by D is equal to 0.05 multiplied by P. We don't know this P. After this equation is and this is a linear equation has been formed. After this we will apply our second balance. So the second balance will be of water. So what will be the water balance? The water balance will be the weight fraction of H2O multiply F plus, as D is also our input, so I think entering will be input will be form input, and we will write it with positive integer. So water 0.15 multiply D, we don't know, is equal to now D is our product is leaving, it is negative, so it will be written on the other side of equation. So it is 0.95 multiply P. So now you can see that two linear equations have been formed. This will be 0.65 if I input my known values, 0 multiplied by 100 plus 0.15 d is equal to 0.95 p. So now these two linear equations have been formed. So now if I write here my linear equations, that will be 35 plus 0.85 d is equal to 0.05 p. And what will be the other equation? 0.65 plus 0.15 d is equal to 0.95 p. So after multiplying this times, this value will become 0.95, and you can simultaneously solve it by cancelling this value, and after this you will get the value of d. So I am not going to solve this linear equation, as if you are on this video for doing a mass balance problem, you already know how to solve a linear equation. So now d will be, the value of d will be 37.5 kg. So now here the value of d is 37.5 kg. For finding p, you can again repeat the same process by multiplying an integer to make the value of d same, and then neglect them and solve the linear equation. But here I can use overall mass balance easily for finding the amount of p. So what will be overall mass balance? F is equal to F plus D is equal to P. So feed is 100 that we have taken as a basis. D is 37.5. So product will be 137.5 kg per R. Kg per R. This will be again kg per R. So in this way, we have seen that how you can basically, so in this video we have seen that if your degree of freedom is not equal to 0, how you can make it equal to 0 and solve a problem. So generally in mass balance you have to make linear equations and then solve these linear equations to find the number of unknowns that are present in your problem. So we will so now we will do again a problem, and in that problem the independent number of equations will become to 3. So the complexity level has been increased from number of independent equations 2 to 3. So this will be the last problem for this video. Inshallah, in the next videos we will I will solve the problems with a difficulty level a little greater than all these 3 problems. So let's start our third and final problem for this video. So now we are solving another problem, that is mass balance without reaction with 3 components, or you can say 3 number of independent equations. So now we will have to start with degree of freedom. The first step is degree of freedom. So the degree of freedom here is, what is the degree of freedom? It is the number of unknowns minus the number of independent equations. So let's see what are the number of unknowns in this equation, in this problem, sorry. So here you can see that the weight fraction of methyl hydroxide or methanol is not known to us. So you can see that, as we already know, that all the mass fractions make if we add them, they are equal to 1. So it is only one thing is unknown, so we can find it is 0.90, so the remaining will be 0.10. So it is not the number of unknown for us anymore. After this we will move here. So you need to find at least 2 weight fractions, so to find the weight fraction of methanol. So now the number of unknowns here will be 2, and plus we also know don't know the B, so the number of unknowns will become 3. After that we will come here. Again here we are given with 2 weight fractions. From these 2 weight fractions we can easily find the weight fraction of methanol. So 0.85 minus 1, so the remaining will be 0.15. So the number of unknowns here is 3. And what are the number of independent equations? The number of independent equations is 1, 2, 3. Ethanol, water, methanol, ethanol, water, methanol, ethanol, water, methanol. So it is 3. So degree of freedom is equal to 0. So this problem is going to have a unique solution, and we are going to solve it now. Before moving to the problem, we will write a general mass balance equation, that is equal to accumulation input minus output plus generation minus consumption. So now, as it is a steady state process, accumulation is equal to 0, generation is equal to 0, consumption is equal to 0. So the remaining will be input is equal to output. So that will be our equation. What type of balances we will use? We will use overall mass balance and component mass balance for solving. Overall mass balance for finding this P, and the component mass balance for finding the weight fractions of ethanol, water, and methanol. So let's start. First of all, so our general mass balance equation has been reduced to input is equal to output. So let's see that we can apply overall mass balance. So we can apply overall mass balance because we know this flow, and only one flow is unknown. So you can apply overall mass balance. So what will be the overall mass balance? Feed is your input, and this P and product are leaving the system. So that will be your output. So B plus P. Feed is equal to is 100. B you have to find, and here it is 60. So B will become 40 kgs. So now B is 40 kgs. So now by applying overall mass balance, you have find your one unknown. Now you have to find all these three unknowns. So we will start with our first, we will apply ethanol equation. So what will be weight of ethanol multiply F is equal to, and our equation is input minus is equal to output. So input is only this, this is leaving, the B stream is leaving, so the weight fraction of ethanol multiply by 40, or you can write here as B, plus weight fraction of ethanol multiply by P. So what will be if I input the known values? So 0.50 multiply by 100 from here is equal to the weight fraction is unknown over here, so P is 40 plus mass fraction or weight fraction of 0.80 multiplied by 60. So now you can see that it becomes 50, 40 WE plus 0.80 multiplied by 60 will become 48. So now you can see that in this equation we are only having one number of unknown. So you can here solve it. 50 minus 48 divided by 40 will give you the weight of weight fraction or mass fraction of ethanol. So if we solve it, so 2 here will be 2 divided by 40, it will be 1 divided by 20, and it will be 0.05. So here the weight fraction of ethanol is 0.05. So now we will apply another balance of water to find the weight fraction of water. So applying water, so I am not going to write this equation. I am directly going to write the values for water. So what is 0.40 multiplied by 100 is equal to, we don't know water here, multiply 40 plus here water is 0.05 multiplied by 60. So now here is 40, here is 40 weight fraction H2O, and here it will be 3. 40 minus 3 divided by 40 is equal to weight fraction of H2O, and if you solve it, so the weight fraction of water will be 0.9925. So 0.925 you will write here, and the remaining thing 0.9, if you add these two and minus from 1, you will find the mole fraction, weight fraction of methanol. So 1 minus 0.975, so it will be 0.025 if I am not wrong. So if I am not wrong, you can solve it. So now in this way we have solved another problem that is related and that was having 3 independent equations. So in this video we have solved 3 problems with mass balance without chemical reaction. In the next video we will solve another 2 to 3 problems that will involve mass balance without chemical reaction, and in the coming videos we will solve the mass balance with reactions and with other genres that will include mass balance, other genres of questions that include mass balance. I hope you like the video. Inshallah meet you in another video. Assalamu alaikum. Please subscribe to my channel.